Okay. Um, so I think everyone is here. I'm gonna start the lecture. Today we'll be talking uh, about basic information about. Let me. Okay. We will see some uh, network uh, network types, computer network types, cloud computing, and what kind of services you can get from available clouds like Azure, AWS, Amazon, things like that. Client server and the very broad view of the architecture of the internet and how things are connected together. This image, this is not a galaxy somewhere. This is a map of all the connected nodes that are out there in the internet. This one shows basically if you the stronger links are showed with thicker basically connections, and those parts that you see are the nodes, uh, are the data centers connected to each other with uh, they're shown with bright dots. So it's an amazing world. Looking at this map, by just looking at this map, you see how many different connections you can see here, and this doesn't even include connections of people like me and you. These are the devices that have a static IP call, so they are a they are a part of this. They are a permanent part of this network, not just me and you that might be connected sometime, and half an hour later not be connected. Uh, I'm just gonna do this. Okay. So we have a very quick review of what type of networks we have. We have wide area network or WAN. Uh, it's several computers are connected through WAN. We have LAN. LAN is a local area network. So when local area networks, like if you go to a coffee shop, for instance, you connected to the router that to the internet that they have in come there. It's coming to you through the router that they have there. Literally, every single person that is connected to that router is connected to to the other person as well. So you're connect if another person is sitting beside you and is using internet and you're using internet through that router, you two make a local area network, or like the people in that coffee shop make a local area network. Now imagine these local area networks. uh, I didn't check. Do we have voice? Can you hear me?
Yes, Professor, we can.
Okay, great, thank you. Now, if these multiple LANs connect, they make WAN, wide area network. And an internet is the connection of thousands of tens of thousands or maybe millions of these WANs, making up the largest network possible for all the computers and making the basically the framework that we call internet. Um uh, we have VPN that you need to know. Does anybody know what a VPN is? What is a VPN? What happens when we use VPN? When we turn on our VPN? Can somebody unmute and tell us what a VPN he or she thinks is? VPNs. When I say VPN, security probably comes to your mind first. Uh, when I want to send my information from my laptop to your laptop, I don't know how many different devices this information has to pass along the way. It may be from here to you, it might be recorded, and my information might be recorded in many devices in between that I'm not even aware of. To prevent that problem when you are sending a sensitive information, uh, you need to create a secure tunnel. A secure tunnel like this, uh, using the physical machines that exist in the internet, which are by nature not secure, because you don't know where they are, you don't know how many people have access to those routers and servers and switches along the way. You don't know. So by nature, it's not secure, it's not safe to send sensitive information. But VPNs can create a path using those machines. This is the important part. It's not a separate machine, but it's a selected, it's a created. It creates basically when you turn on your VPN, it creates a tunnel, a safe tunnel for sensitive information to pass that unsafe environment without anybody knowing that. So encoding and decoding involves, and so many other things. So this is what we mean by tunneling, and this is also part of the internet and important part when it comes to security. uh, and we have MAN, Metropolitan Area Network. I don't know if you've heard about it. Uh, so the difference between this is also a network, but typically it is a, a geographical parameter comes in. So this is a network of maybe a town or a city, or this is a network of a public transportation. So if you get on if here TTC for instance has its own MAN, um, the this is the same thing. Wide area network. Sometimes if it is for a city, for instance, imagine how big that could be. Uh, but the geographical property comes in that differentiates MAN from WAN. And in WAN, it can be a network of computers in several different countries. That's fine. But typically, when everything is within a geographical boundary, uh, it's called this type of network called MAN. Um, why why internet has been so successful so far? Oh, by the way, let me see if I'm recording this. Am I? Yes, there we go. Why why is internet so successful? Guys, believe it or not, ladies and gentlemen, believe it or not, you can nothing can be successful except they involve and they implement some standards. Why? Because in this case, so many people other than the designers, can understand that thing and can contribute to that thing. So, internet was one of those things that, because of the uh, wide range application that at that time, at the very beginning, they realized that it can be a real thing, a real game changer. Uh, there's a lot of standards involved in that. The first standard from hardware level, if we want to speak, You probably know that the first time they connected two computers, both of them crashed. Uh, it was, I think, if I remember correctly, it was in the one of defense projects of Pentagon. So they both crashed. But now millions of billions of computers are connected, and the invention of IP gave each computer an identity. So computers could be identified using this number IP, although they ran out, and now we are doing IP6. But in general, TCP/IP was one. This is the protocol, and the mostly in the hardware level is how connected computers can recognize each other. How a computer can have an identity in this network of composed of billions of computers. Then HTTP, Hypertext Transfer Protocol. It was a protocol for communication. Now that we are connected, okay, how can we talk? Who's gonna talk first? Um, who's gonna respond? Who's talking to who? And all these things were standardized in this HTTP protocol. And when you in a web browser, when you type HTTP and then that website, that means you are communicating with HTTP protocol. Which is the backbone of the internet. And then comes HTML. Now that we recognize each other, and now we know how we should, like in what order and what, how we should talk to each other. Now, what is the standard language to talk? And that was the HTML, hypertext markup language. That was the language. We said that it's not a programming language; it's just a markup language that uh, is a standard way of putting content together so that that content can be readable and can be referenceable to other contents. And this was the language of this network. And www, www is not internet, is uh, is a framework, in that internet is all those billions of machines that are connected, right? I will show a map very soon. uh, but inside that infrastructure, that internet is that infrastructure. Inside that infrastructure, there is a framework within which you can uh, build websites, communicate, and things that mostly they are familiar with, with www. Because what we see and what we do is almost 100% within this framework. But there is other parts to the internet than www. One of the things that you may be interested is the dark internet, basically things that gangs use, or we hear a lot about this. That is not part of www. That runs also on this internet infrastructure, uh, but it's not World Wide Web. Uh, so this is a framework for all these talkings and all these good things that happen that we're familiar with. And browser is a basically is an interface, is a window, is a tool for you and me to access to input and to get information and to interact basically with this wonderful world of connected computers. Another reason internet is successful is it's open source. Nobody owns this. All the codes are known, and we have GNU licenses for that, and everybody can contribute. When things are open source, it means everybody can contribute. Obviously, everybody when reaches to thousands to hundreds of thousands of people, that thing gets really, that thing can get updated really fast, and that's what we see these days. It's worldwide. Nobody is deprived from accessing that. Everybody can access. Obviously, it's affordable, and the cost for access is getting down and down. It's decentralized. Nobody, no country owns the internet. Every country, like many countries, by decentralized means those nodes, those backbones of the internet are distributed along so many different countries. Nobody can say, okay, internet is mine. I'm sorry, I'm not gonna give it to you. Everything is locked. Good luck. Go invent your own internet. No, it's not like that. It's distributed, and it's neutral to every single packet. It doesn't prioritize my request to access a website over your query. Everything just handled. Everything just gets handled in the first come first base order, mostly. So when the server receives a request, it doesn't look, oh, it's coming from this person. He's an important person. Though. Let me prioritize this. No, there's no such thing. So uh, this is another key to internet become widespread and successful. For the internet, it's good to understand. You might not know this, but to be this internet that we are using are categorized in three different tiers or parts. We have the the big boys, uh, tier one. These are very large infrastructures, data centers, uh, talking to each other, and smaller ones are tier two, smaller ones tier three. What's important in this model, in this internet model, tier model, is that anybody from the same tier can just communicate without paying anything. You don't have to pay if you're a tier 2 server talking to a tier 2 server. But if you are talking to a higher level tier, you should pay. That means tier 2 pays to tier 1, tier 3 pays to tier 2, and you and me as users, main users of this infrastructure, pay to tier 3. Tier 3 is the ISPs, internet service providers, that we have, like Bell, Fido, whatever. These are internet service providers. These are tier 3 nodes that get you connected to the internet. And tier 2 and tier 1 exist in large buildings like this. For instance, these are internet exchange ports. When tier 1 and 2 want to get connected to each other, now these are real infrastructures. So for instance, these are three buildings: 151 Front Street West, uh, 905 King Street West, 45 Parliament Street. These are the buildings that tier 2 machines come and get connected to tier 1 machines. Large infrastructures uh, composed of a lot of switches, huge data centers, and stuff like that. Um, so this is what we in reality we have. You might have passed any of these buildings without noticing what huge thing is going on there. Just go to Google Map and look at the rooftop of these buildings. uh, it's astonishing how many fans and chillers they have just to keep this building cool. These are some on the map. We have a lot of these buildings all over the world. Um, Three of them were in Toronto, and we have many of them all over the world. It's amazing. Now look at the connections. These are typically fiber optic cables that connect these tier 1 and 2 centers. It connects them, and the ones you see in orange is the cables. These are under the ocean cables by Amazon, Facebook, Google, and Microsoft. For these four uh, giant companies, they have their own fiber optics connecting their own servers. For instance, Google had 13 data centers. These are tier 1 and 2 data centers, uh, and they are able to handle trillions of queries happening every day. Or YouTube, for instance. Like I have this here, 400 hours of video upload happens every minute to YouTube. Like every minute, more than 400 hours of video is being uploaded to YouTube. This is 2021, um, based on 2021 data. And you see this huge connectivity. These are the things in some countries, mm, they may lose internet uh, countrywide, and that happens when they lose connection to one of these uh, basically one of these fiber optic cables or connections or cables, mm, which is difficult to lose connection, but sometimes happens. Um, some keywords that we need to know the meanings. Browsers, you know that search engines, we know that content creators are people like you and me. We create contents, app and platforms. Stacks are programmers, again, you and me. Uh, Hosts are those basically data centers that can host your information, your websites or whatever. ISPs are internet service providers, tier 3 uh, server owners that connect you and me to internet. Transit providers, these are tier 1 and 2 that connect tier 3 and make you and me possible to use internet. CDN or reverse proxy, these are the servers that are just there to cache some data. These are RAID. They're called RAID system for hardware for hard drive backups. So you can think of them as gigantic servers that just cache and store data, keep data, so that uh, it's every time you want some data to access the same data, there's no need for that to get processed. So you have a copy of processed copy of that. They just send you, and also they help. They are basically internet's backup. And we have domain name servers, DNS, domain name servers or systems. They keep track of existing domains. And when you type like www.google.com, it gets translated to an IP in one of those domain name servers. And we have we have authoritative and root DNS. These guys are official. So you go to Whois. You want to buy a domain. Whois is one of those. Whois that. If that's available, you just buy. Registers are also registers are basically those that registered these domains, keep track of registrations, and registries are the bodies that govern basically top level domains like domains like .ca, .gov, things like that. Very very useful to know these terms. And now you're familiar with problems of internet. Everybody every day can hear about dangers of this and security issues. I have a list of that: hacking, phishing, ransomware. Ransomware is something that they access to your private information and they want something, usually money, um, and otherwise they say that they will publish this information. Or DDoS we have. It's a distributed denial of service. That happens when a server uh, a server receives so many queries intentionally. People like these bots make those queries intentionally to to make the server out of access. So it basically the server crashes. So it receives so many queries that it cannot process and reply to them. One of the things you see when you want to log in or do something on a website is uh, if they show you numbers, you have to now pick some numbers or pictures or say I'm not a robot or things like that. That's because they want to they don't want this to happen. Otherwise, everybody could send like these bots would send queries, and this could be a problem. So safety is a problem. Cyber security is a big thing. If you're interested in cybersecurity, that can be a really well-paid job for you, and dealing with all. And it's, by the way, I'm not gonna lie. I love cybersecurity. It's an interesting part um, of being in this business. We looking back in the history, we have we have received here recently passing two different platforms. The first one was just you and your computer. So it was the the terminal you had. It was you and your computer. Everything was limited, hardware, software, difficult to use. And then in the second stage, it was the two-tier design, which was a server or a mainframe, and you as a client could access that uh, using some protocols to access some information, some data. And then the third tier started by connecting all these mainframes basically together, and that created the cloud. So is nothing cloud is nothing but connected mainframes that used to serve uh, uh, alone in the past, but now we have a connection of those. By connecting those, we are sharing resources, guys. Now we have um, uh, I have something to give to the public. Some other person can use what I have and give his or her own product. So this is the way we can share resources, and the cost reduces. Everything gets more efficient. We access to cloud. Now, when accessing cloud, composed of three parts, and now you can have limitless, basically, literally limitless models. You remember we discussed model, controller, and view architecture in design. Uh, so for the model, you have limitless possibility for databases to just upload to the cloud, limitless controllers, multiple different controllers. You don't even know where these are which computer these are running on, but you have the source, and multiple views. You can have one computer accessing to cloud through different windows, seeing different things. That is a huge thing, an amazing thing in this model. Why the recent, basically a stack type of development, following that model, viewer, and controller architecture is possible now in the connected infrastructures, mainframes that were serving people in the past without being connected to other servers. Now, this connection has created cloud. Uh, well, if you ask your grandma what a cloud is, she may show you this, but we know that clouds really look like this. This is a real picture from a Google's data center in Oklahoma. So you see these mainframes, these are connected through internet. All these machines are connected inside that infrastructure that we called internet using TCP, IP, HTTP, and all the protocols that exists in the internet. And all overall, they they create cloud that you can do what with your cloud? You can do many things. So uh, these are if you look at these, we had this image in our previous slides. Everything here is the edge device or the user or the client, everything. And you don't see only a computer. You see a smartwatch, you see an industrial valve or something, um, smartwatch, some other stuff. So all these that you and me people are using are the client sided thing or the edge devices. And when they are connected to a higher level composed of millions of these mainframes and servers, that becomes the cloud. And this cloud now is connected to gigantic uh, data centers uh, and create this uh, huge possibility of internet and cloud computing. What is cloud computing? Cloud computing is basically whatever you do using not using your local machine, not the machine that you have, but by using whatever is on the cloud, uh, using internet. So all these things happen using internet. There is no private connection to those. Everything is public internet. You're using internet. And uh, using basically distributed computer. Why distributed? Because now that these servers are connected, why keep only one of them busy? We can run our programs simultaneously on multiple machines, and this is called distributed computing. Every part of your computation is taking place in a different machine, and then the result becomes one. You merge and you get the result. It's important to understand in a modern world, if you want a service from a cloud, it's very important to realize and to know what kind of different service you need and you want to buy. Three different services are available these days in modern clouds. We have software as a service, we have platform as a service, PaaS, PaaS, SaaS, PaaS, and IaaS. It is infrastructure as a service. Uh, Starting from this one, infrastructure, let me see if I have it here. Infrastructure is literally the hardware that they give you. AWS, Azure, you go there, say, okay, I want to, um, I have my own company. I don't want to buy my server, my mainframe, or whatever. I want hardware from you. I will install. So by hardware, they will give you the hardware, networking tools, and everything ready. But you need to uh, create your own operating system or choose from different options that they have, customize it, basically take care of your own operating system or operating systems on the same piece of hardware using virtual machine and things that we've already discussed, and then uh, do whatever you want. So what they give you, what these bodies give you, is the hardware infrastructure. Platform as a service is different. In platform as a service, they have their operating system also installed, everything defined, like file storage system defined, everything defined. They give you basically a computer with uh, operating system and some other main applications, some system, some applications that are important for maintenance of your system and blah blah, are already installed. One example is uh, FTP servers, file transfer servers. So you have, you want to just store your data. For instance, OneDrive. OneDrive is a platform. Well, it can also be a software, but it's mainly platform. It gives you the hardware and the operating system. Everything is ready. You upload your data there, backup your data. This is the difference. So in platform as a service, you also receive the operating system and some preliminary applications, fundamental applications that is necessary for the good of that platform. The last thing we can get from them is software as a service. This is very popular. This is what many people like you and me are exposed to. We are end users, are exposed to software as a service. When you're downloading an app, when you're using an app, whatever you're doing, whatever software we are using, which is a cloud-based service, is called software as a service. I'm not talking about the Windows that you have installed on your own machine. It's not, it doesn't need any cloud connection. I'm talking about the applications that run on your, on the server, and you just have a window, a front end window, and by sending queries and receiving JSON or XML, you can use that app. These are software as services, and end users like you and me are very familiar with that. Other parts, PaaS, are for application developers. If you want to develop an app, you need this service. You need to buy this service. Why? Because you need a hardware and you need an operating system out there. Then you sit down, write your app, and run it on the server and sell it to other people. And in the infrastructure as a service, obviously network people are involved because they just give you the hardware, and everything else you have to take care of by yourself. Think about it as a think about it as a pizza. You want a pizza, it can come to you in multiple different forms. The blue ones are the things that you manage, and the orange ones here are the ones that are already managed for you. If you need a pizza, you can start making it yourself. Everything from scratch: dough, cheese, uh, whatever, vegetable, sausage, whatever, every single thing, you take care of that. That is that is on premises. That's called on premises. That means your machine is on your premises, is on your desk. Your machine is in a separate room in your company. Everything is done by yourself. You have to handle hardware, you have to handle operating system, you have to handle applications, everything. But if you want a pizza, you go to the store and buy a frozen pizza. That frozen pizza, in terms of ingredients, everything, it's been taken care of for you. And what you need to do is just bring it home and cook it. That kind of thing is similar to infrastructure as a service. When you are buying an infrastructure as a service from a cloud service provider, uh, it's similar to buying a frozen pizza, but the rest you have to take care. When you order pizza, they bring you the pizza, it's ready. Uh, Everything from making to cooking has been taken care of. Uh, but you have to call them and ask them, uh, order the pizza that you want, and you have to wait so that they make it and bring it for you. This one is a platform. So in platform as a service, we said the last step is you. You should create your app, run it there. Just pick up your phone, call them, tell them what kind of pizza you want, and they will bring it to you. Serving, eating, this is your responsibility. And now, if you go to a food court, everything is ready. You just show, I want that slice of pizza, and you eat it right away. That's software as a service. Everything is ready for you, from hardware to operating system to the application. Are we good with these so far? Let's take a poll. Does everything make sense? Does everything make sense? If not, please ask your question. Okay, and now I think we are good with these. Just couple more. Uh, I explained IaaS platform. I also explained software as service. Another interesting thing that we have is peer-to-peer connection. Peer-to-peer connection uh, is two computers connected to each other, and they have access to each other's resources. Uh, as you might think, this is a big security issue because without any protocol, these two computers can have access to each other. And blockchain was one of the solutions for this. In blockchain, uh, basically, you use hash, which is a specific protocol. Things are coded in that hash, and then nobody understands except for those two parties. And also, uh, there is more layers of security added to this peer-to-peer or P2P networking thing, which is again through the internet, but different protocols. This is, for instance, different from www, World Wide Web. It has its own protocols and stuff like that. Um, okay, that takes us to the end of lecture for today. In the activity, this week's activity is easier than last week. I'm happy to say that, but still, you need to uh, spend a good amount of time on this. You have only three questions. The first question uh, is go ahead and use some Microsoft 365 cloud-based services, which includes OneDrive, and includes other softwares like Microsoft Word, Excel, PowerPoint, stuff like that. And then categorize these services in question to categorize them in three different categories. Are you using infrastructure as a service? Are you using a platform as a service? Or are you using a software as a service? You put them in a table. And the third one is basically we wanted to you to think about different kind of services that are available in the internet and talk about those. So this is an essay type question. You will write. There are two topics. Uh, you'll choose one of them and will write and will write what you think. And there is a last question that asks you uh, to go back by probably 2 months or the beginning of the term and uh, see the changes, see the things that you have learned, and now what are you interested in? What has been changed in your thoughts and in your thing about ICT and uh, about the thing that you want to do in the future. It's easy, but you have to spend some time. Again, there are some quizzes for those who are interested, but they will not be covered in our lecture. In the quiz, sorry. Okay. Uh, any questions? Okay, if not, let's watch Parvinderjeet presentation today, which is her interest about 3D printing. Let's watch this. At the end of the presentation, please feel free questions from her if you have any. I'm gonna.
Hello
Oh
everyone,
wait,
this is
wait, wait.
Parvinder Kaur.
I think you don't have. Okay. And I'm gonna share it. Share with system audio. Okay, there we go.
Hello everyone, this is Parvinder Kaur. Today I'm giving presentation on a very interesting topic, 3D printing. 3D printing is also known as additive manufacturing. 3D printing or additive manufacturing is the process of making three-dimensional solid objects from a digital file. The creation of a 3D printed object is achieved using additive processes. In an additive process, an object is created by laying down successive layers of material until the object is created. Each of these layers can be seen as thinly sliced cross-section of the object. 3D printing is the opposite of subtractive manufacturing, which is cutting out, hollowing out a piece of metal or plastic with for intense milling machine. 3D printing enables you to produce complex sheets using less material than traditional manufacturing methods. Our next step is what the 3D printing process is. While it might sound complicated, 3D printing is fairly easy to understand, at least in principle. It is accomplished by a series of steps from design to final production. Here is a brief breakdown of how 3D printing works in practice. Our first step is 3D modeling. The process of 3D printing begins by making a graphic model of object or part to be printed. You can opt to download a part design from an online 3D design library if you want to print something generic, or you can create one from scratch if you have a specific design idea or objective. 3D printing files are typically designed using computer aided design software packages. These modeling stage allows designers to customize every detail of their final part. The remarkable precision is one of the aspects of 3D printing that is most revolutionary, and working in such detail and complexity is opening up new possibilities for designers and manufacturers. Our next step is testing and simulation. This optional stage can help freeze and plan for potential problems in our design. Simulations can test a wide variety of our object properties and can help you to design team or your team hone your design until you arrive at a design that is ready to be printed. This stage is especially useful if you intend your product to have certain characteristics. For example, in the automotive or aerospace industry, many 3D printed parts must be aerodynamic. Testing the airflow of a product before printing can help save time and save money later. Once you have a printable file, the next step is to prepare it for 3D printer. Our next step is 3D slicing the model. Once a design is finalized, then the next step is sliced it. Since 3D printers work in layers, the printer itself cannot technically work in 3 dimensions. Instead, each model is sliced and then the printer creates each individual slice, the result of which is the 3D object. The basically means slicing 3D model into hundreds or thousands of layers that will be delivered to your printer. A sliced file will also tell 3D printers where to fill a model and where is to be left vacant. For example, if 3D printer object has internal lattices or a net, then the empty space becomes just as important as what printer prints. This step is accomplished with a specialist slicing software that might include softwares like Simplify 3D, Graphiware, or Astroprint, etc. The slicer software will also add support columns if they are needed. These columns can be used to form the base of a design or a support structure for printing, but it can be easily removed post printing. Think of this almost like scaffolding it. It goes up to support a building project and later is removed, leaving absolutely no trace on the finished building. After your file is sliced, it's ready to 3D print. Files are typically transferred to a printer by USB, SD, or Wi-Fi. Once this is accomplished, it's over to the 3D printer. After slicing the model, our step is 3D printing. After the modeling and slicing of a 3D object, it's time for 3D printing. In this stage, the printer acts almost the same as traditional paper printer. It receives the information and print layers after layers of your chosen material, reflecting the process of hundreds or thousands of time until the 3D object is completed. Our next step is post-processing. This optional stage is used for finishing or to remove any spot structures required during the printing of your final project. Our last is the example of 3D printing. 3D printing encompasses many forms of technologies and materials as 3D printing is being used in almost all industries you could think of it. It's important to see it as a cluster of diverse industries with a merit of different applications. As few examples, consumer products, eyewear, footwear, design, furniture, etc. Industrial products, manufacturing tools, prototypes, functional and reuse parts, and data products, prostheses, artificial scale models, and reconstructing fossils, reflecting ancient air, art crafts, constructing evidence in forensic pathology, movie props, etc. These are some examples of 3D printing. Thanks. This is my today's presentation. Thanks.
Okay, thank you. Does anybody have any question about the presentation? Mm, nice presentation. I have one question. Have you ever printed anything using a 3D printer for yourself or for a company? Are you there, Parvinderjeet?
So your voice is not clear.
Oh, How about now? Do you hear me? Let me stop sharing. How about now? I asked, have you ever? I asked if you've ever printed anything using a 3D printer.
So I haven't used 3D printer yet, but I have a huge interest in 3D printing, how 3D printing works. So I planned in future to work 3D printer.
Yeah, sure. It has a huge industry, and you need to be a good programmer if you want to build one of those, uh, or probably to print one. Printing is easy, but yeah, there are companies that are making these 3D printer machines. Thank you so much. It was interesting. Next week, we will not have any lectures. It's the week that you rest, and we will start beginning from July again, the first week of July. If you have any questions, please ask. All right, then we'll see you in 2 weeks.